Hello, my name is Rebekah Emery, and today we will be learning about Module 1, Critical Thinking and Number Sequences. Let's solve for this equation. Our first equation is composed of a diagram which gives us 4 orange numbers with 4 yellow circles. The top right circle has a 6. The orange numbers are the sums of the yellow circles on either side. For instance, we need to find the number that can be added to 6 for a sum of 13. Our top left circle will be 7. Moving down from 6, we need to find the number added to 6 that will be equal to 21. We will add 15 to the bottom right circle. Next, moving across the bottom of our square, we find that our next sum is 19. We need to find that number added to 15 to equal 19, we will add 4 to our last yellow circle. Finally, by checking the left side of our problem for an accurate equation, we will determine if our equation is solved. 4 plus 7 does equal 11. This equation is complete and correct. Next, we will take a look at perimeter. Perimeter is the measure of the distance around the shape. Think of it like a fence. Using the same 9 tiles, you could make many different shapes. Each time a new shape is created, there could be a different perimeter. Using the 2 examples on the screen that I've made, let's see how this works. Which figure shows the greatest perimeter, and which shape shows the least perimeter? Beginning with figure A, where the tiles are arranged in a single row, let's find the perimeter of the shape. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Now let's look at figure B and find its perimeter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Notice how the arrangement of the tiles affected the perimeter of the shape. Later, you'll be able to experiment with tiles at your desk to design shapes that have different perimeters. Remember that shapes can be irregular and do not have to have strictly straight sides. Next, let's look at a number pattern. At first glance, this string of numbers 1, 5, 12, 22, 35, 51, 70 doesn't seem much like a pattern at all. Yes, the numbers increase each time, but the amount appears to be very random. Without the benefit of the illustration and the corresponding number sentences, it would be very difficult for you to understand this pattern. I hope that by cracking the code on this pattern, you will gain insight on more complex ways that patterns can be discovered. We begin this diagram with 1 dot right here, that little black dot. Then we added 4 dots to the diagram to form a pentagon. Look carefully at the pattern of each number or sentence. See what's happening? You're adding 3 to the last entry of the previous number sequence. The numbers in this complex pattern become more obvious when you look at the sequenced equations. The formula for a pentagonal number is Pn equals 3 times n. Pn equals n times 3 times n minus 1 divided by 2. Using this formula, you can find any pentagonal number in this sequence. For instance, if we plug in the number 10 for n in this equation, you can see that it gives us the correct pentagonal number for the 10th number in the sequence, which is 145. Our next activity involves a number pyramid. The concept is simple. The blocks are stacked in a brick-like pattern, the brick that sits on top of the two bricks is the sum of the two bricks below it that it is touching. Critical thinking comes into play because there are some important numbers that are missing. Where do we start? We know that z and y equal to 27, but how do we find z and y? So we have to move to the bottom row. You might first think, okay, this is easy. If y, the middle row, is equal to the top row, then the bottom row should equal to the middle row. But we soon realized that that doesn't work because x has to be used twice. We add it to 2 to find z, then we also add it to 9 to find y. We need to find a formula to help us solve the bottom row first. Moving from the left to right, we need to add 2 plus 2x plus 9 to equal 27. Everything on one side of the equal side has to balance with what is on the other side of the equal sign. I need to get x by itself on one side of the equal sign. To do that, I'm going to add 2 plus 9, which is 11. Then I'm going to subtract 11. Since I subtracted 11 on this side, I'm going to also subtract 11 on the other side. So I will divide. Now I'm going to go down to 2 times 2x equals 16. Then I will divide 2 on each side, and then I will get 8. Now I have x equals 16 divided by 2, which is 8. When you plug 8 into the pyramid for x, you are able to solve for z and for y in the middle row. Finally, you can check your work to see if your answers are correct by adding z and y together. Z equals 10 plus 17. 10 plus 17 equals 27. Our answer is correct. This equation is complete. The next question is actually a puzzle. We're going to solve the puzzle using clues. We're given the names of 4 men, 4 women, and 5 clues. Our job is to figure out who is married to who based on the information that we are given. The ladies in this puzzle are Kitty, Sarah, Josie, and Ann. The men are David, Will, Floyd, and Gus. We are told that Floyd is Josie's brother. Josie and Gus dated some, but then Gus met his present wife. Kitty is married to Will. Ann has 2 brothers, and Ann's husband is an only child. In order to solve this problem, we will need to find the most obvious clues first and then move on to the less obvious. The process of elimination, we will be able to successfully figure out who is married to who in this puzzle. First of all, Kitty is married to Will. Next, we know that Floyd is Josie's brother and that she has dated Gus but didn't marry him. With that information, the only other option for Josie's husband is David. Third, we know that Ann's husband is an only child. Since Floyd is Josie's brother, it can't be Floyd. The only option for Ann's husband would be Gus. That leaves the only option left for Sarah is Floyd. In the diagram, I have tried to highlight the information used throughout this puzzle to solve it. Notice there was a statement in the clues that was useless information. Hint, don't let that trip you up when you are solving problems similar to this one. Just know that there will probably be something extra in the clues that you will not need to solve for the problem. Our last problem actually has 2 parts. The first part of the problem asks us to move dots to turn the trapezoid into a rectangle. Look at the third trapezoid shape. If you move 2 green dots to the bottom row, to the top row, you will get a shape that has 2 more columns than rows, which is a rectangle. Now for the second part of this problem, the first trapezoidal number is 1 row of 3 dots. We could represent this first row as n times n plus 2. Insert the number of the row in n equals 1, which would be 1 times 1 plus 2, which is 3. 3 is the first trapezoidal number in this sequence. The reason we multiply by the number of rows will be necessary as we add more rows. Moving to the second trapezoid in the sequence, you can see that we added an extra dot on each side to make a total of 5 dots in the pink row. Our trapezoidal number for this shape is 8. Let's see how this looks using our formula of n times n plus 2. Substitute n with 2, and you get 2 times 2 plus 2, which is 8. Moving to the third picture, again, a row is added with 2 extra dots, 1 at each end. Checking the formula, we can see that 3 times 3 plus 2 equals 15. The trapezoidal number for our third number is 15. The formula for the trapezoidal number sequence has worked consistently. Now let's try to solve for the fifth one, the fifth trapezoidal number. We're using the same formula, n times n plus 2. Substitute the n with the 5, and you have 5 times 5 plus 2, which is 35. If you take the time to count the dots in the trapezoid, you will find that there are 35 dots in the fifth trapezoidal number. Using this formula, you can find the trapezoidal number for any number in the sequence. Well, this concludes our lessons for today. I hope that I've helped you to better understand the concepts presented. If you have any questions, I'd love to have the opportunity to clarify so that you can be confident in your ability to use critical thinking to solve problems in the number sequences. Bye.